System is one of over 500 known solar systems in the entire Milky Way Galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own Sun. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the Sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home. Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, and the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
EPIC is an Earth science instrument aboard the Discover satellite, which launched in February 2015. The spacecraft always remains between the Sun and the Earth, approximately 1 million miles away, at a special gravitational balance point known as Lagrange 1. From this view, EPIC sees the sunrise in the west and the sunset in the east at least 13 times a day. The haze, seen around the edges, is due to scattering of light by molecules in the atmosphere. Scattering is also what makes the sky appear blue during the day and red at sunset. The colors shown are our best estimate of what a human sitting at the location of EPIC would see. EPIC takes at least one set of images about every 2 hours. The camera records each set in 10 different wavelengths. At least 3 separate wavelengths, red, green, and blue, are combined to produce this color view. In March, the moon passed between the Earth and the Sun, causing a total solar eclipse. During the eclipse, the moon cast its shadow over a portion of the planet. If we slow the video down, we can see the moon's shadow make an appearance right about now. Although the view from EPIC is only once every 2 hours, we're able to track features like the motion of clouds. Around 2/3 of the Earth is covered by clouds. Clouds reflect light from the sun, helping to keep the planet cool. They also trap heat rising from the surface, keeping the planet warm. Changes in cloud cover affect the heat balance and how warm the Earth becomes, which is one of the reasons why we study them. The hourly images of the entire sunlit side of the Earth provided by EPIC will be used to study the daily variations of features over the entire globe, helping us to better understand and protect our home planet.
Earth. The Moon is our Earth's partner in space. It orbits the Earth. The surface of the Moon has many deep holes called craters. There are rocky mountains and flat areas also. We can see it brightly in the night sky because it reflects the light of the sun. It does not produce light of its own. During the day, the sun's light is far too bright, so the moon, though present in the sky, is not visible. And even if we can see it, it is not as bright as it is during the night. The moon is Earth's satellite. A satellite is a body that orbits around a planet.
that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice, too, that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed.
This is Earth. You live here on this planet somewhere, and everything that you've ever known is located right here. But just how small exactly is Earth when compared to the scale of the entire universe? Let's start by zooming out to where we can see our nearest cosmic neighbor, the Moon. You may think that the Moon is very close to Earth since it dominates our night skies, but in reality the Moon isn't this close to our planet, it's actually about this far away. 384,400 kilometers away from you right now on average. You could fit 30 entire Earths in between this distance, and if you somehow were able to drive a car at a constant 100 kilometers per hour speed, it would take you about 160 days to drive the entire distance. Despite this incredible distance, however, 12 humans have actually set foot here, representing the furthest away that any individual human has ever been away from the Earth, and one of humanity's greatest achievements. This is what the Earth would look like from there if you were standing there with them, and if you wanted to communicate with somebody back at home, it would take a message about 2.5 seconds to travel between you and them, since that's how fast the speed of light can travel at. This is a photo that was taken on Mars, and that tiny dot that you see there is Earth as seen from the Martian surface. On average, Mars is an incredible 225 million kilometers away from Earth, but that distance can be as high as 401 million kilometers. That means that whenever humanity finally gets around to landing a human on the planet, that person will be 986 times further away from Earth than the astronauts who landed on the Moon were. In addition, the time delay for sending a message from Mars back to Earth isn't just 2.5 seconds, it's actually more like 20 minutes each direction, which would render instant communication in the event of an emergency impossible. When we zoom out even further away, we can find the Voyager 1 space probe, which is the furthest away man-made object from Earth. It is currently located 138 AUs from the Earth. AU meaning astronomical unit, which is the distance between the Earth and the Sun, which means that Voyager 1 is 138 times further away from us than the Sun is. At some point on its long voyage, Voyager 1 turned its camera around and took this photograph. It may not look like much at first, but in my opinion, this is the greatest single photograph ever taken in all of human history. This tiny, pale blue dot is Earth, and I don't think that anybody has ever said something as amazing about this as Carl Sagan when he said, "If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you ever heard of, every human being who ever lived out their lives. The aggregate of all our joys and sufferings, thousands of confident religions, ideologies, and economic doctrines. Every hunter and every forager, every hero and coward, every creator and destroyer of civilizations, every king and every peasant, every young couple in love, every hopeful child, every mother and every father, every inventor and explorer, every teacher of morals, every corrupt politician, every superstar, Every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Voyager 1 is currently traveling at 17 kilometers every single second, but even at that speed, it won't break out of the reach of our solar system for another 30,000 years. Once we go beyond the solar system, we arrive in our interstellar neighborhood. Here we shift to the light-year unit of measurement, which is the distance that light travels in a full Earth year, or about 9.461 trillion kilometers. The star Proxima Centauri here is the closest other star to us other than our Sun, but it's still 4.24 light-years away from us. To put that into perspective, if it was heading in the right direction, it would still take Voyager 1 over 70,000 years to reach it. In other words, if you drove your car at 100 kilometers an hour like in our previous example to the moon, it would take over 6 times longer than the entire age of the universe is just to finally get there, and it wouldn't even exist still when you arrived. When we zoom out even further, we can see the entire Milky Way Galaxy, inside of which Earth is located right here. This yellow dot is the furthest extent of humanity's radio broadcasts throughout history, which means that any possible aliens who live outside of this range are totally unaware of humanity's presence. It's complete silence outside of this yellow dot as far as we are currently aware, but the entire galaxy spans over 100,000 light-years from end to end. There are over 100 billion stars and over 100 billion planets inside of our galaxy. But you have never seen the full glory of the galaxy at night, because 99% of the stars that you can see with the naked eye are limited to this small, tiny region right here. But even this massive galaxy is nothing compared to the rest of what's out there. Zooming out even further and we arrive at the local group of galaxies, a collection of 54 different galaxies that is about 10 million light-years across. But zooming out even further and we can see the Virgo Supercluster, of which the local group here is just a tiny segment of. There are at least 100 other groups of galaxies just like our own local group inside of here, and the distance from one side to the other is a mind-numbing 110 million light-years. But even the massive Virgo Supercluster is nothing but a quiet and tiny lobe of the Great Laniakea Supercluster, an enormous structure that is home to our galaxy as well as 100,000 other galaxies. The distance from one side to the other is 520 million light-years, but from even there we can zoom out all the way to the entire observable universe and see that even the titanic Laniakea Supercluster is just a tiny and insignificant part of everything. This is the observable universe, and it contains everything that we know of. It is home to at least 2 trillion different and individual galaxies, which together contain more stars than there are grains of sand on the entire Earth. The distance from Earth to any side of the observable universe is 46.5 billion light-years, which means that the entire width is 93 billion light-years across. What's perhaps even more interesting, however, is what actually lies beyond the observable universe. Keep in mind that the observable universe is all that we can currently see, and it's entirely possible that the rest of the universe outside of it is vastly larger and more fantastic than we can possibly ever imagine. We simply don't know what else is out there, because the light from these incredibly distant places has not yet had enough time in the universe's history to reach us yet back on Earth. And the light from some places may never reach us at all. Because some parts of space very far away from Earth are expanding away from us faster than the speed of light, that means that the light from these places will never, in an infinite amount of time, reach Earth. Meaning that even if humanity is eternal and exists forever, there will still be an unknown number of places in the universe that we will never know about or ever see. So, it is very likely that as unbelievably enormous as it seems, the observable universe is just a tiny slice of what we can currently see of the entire universe.